Hi guys and welcome. So in our previous video, we got to understand end-to-end data segmentation, and we got to understand that it's a technology that we've been using in networking for God knows a very long time, and it's been there through campus networks, through um, service provider networks. They use it everywhere. So we are looking at how to leverage on this technology to build upon our test case where we are going to have, let's say, a tier 3 ISP, which is currently facing an issue with creating something like a segmented network for its clients. So we'll get to understand that. But in the meantime, let's look at the MPLS architecture. So this is a typical MPLS architecture. So this is a typical MPLS architecture, right? So at this end is what we call CE. That is the customer edge device. And here is the PE, that is the provider edge. It can be an ingress or an egress. Egress simply means that this customer is ingesting traffic into the service provider core network. And then it's going to use a label switched path to connect to the routers in the core ISP's core all the way to the last egress router. And then we have another C, which is for the customer at a different site. Now, the technology used by MPLS is one LDP, which is the label distribution protocol, which is responsible for allocating labels for all prefixes within the ISP core. And then we also have what we call BGP VPN v4. So the BGP VPN v4 also allocates labels to customer prefixes under each VRF. So the VRF that we have here. So VRF simply means that creating a logical router within a single router. So for example, we can have a big router over here. And by default, it comes with only one routing table. So one routing information base. But then with the concepts of VRF, we are going to have a very big router with different routing tables for each client. So let's say we have a customer A1, customer B2, customer C3. Now each customer will have his or let's say now each customer is going to have their own routing table in this one single router, which is basically trying to tell you that we are segmenting data traffic from each customer. So you have this customer here connecting to this ingress router. We can as well have a different customer here. So let's say this can be in VRF A. This one can be in VRF B. Now in the end, when the traffic gets to this end, the job of LDP is to carry traffic. And in MPLS, ingress and egress routers identify themselves by their router IDs, or let's say the loopback. So for example, LDP is going to forward traffic to this router. So let's say if this is the egress router, it is with so the destination for, let's say, a route coming to this side is going to be the loopback or the router ID for this particular router. So throughout the ISP core network, is going to assign LDP labels to be able to identify this particular router. Now, this router is forwarding a lot of traffic. Let's say it's forwarding traffic for VRF A and the same for VRF B. Now, after LDP has transported, or let's say moved the data traffic for all the customers from this particular router all the way to this side, It's a job of the BGP VPN v4 label to know which traffic is going to which customer. So we have the route distinguishers, and then the route targets, import and export, playing their role here, so that this router will know that, okay, so this traffic is destined for, let's say, VRFA, and let's say this traffic is destined for VRFB for, let's say, customer B2, and here's customer A1. So basically, we have data segmented throughout the service provider core. So in ISP environments, you're going to see, let's say, over thousands of interfaces for the client end. And the job of this router is to create separate routing tables for each customer, and then to push it through the MPLS core to the various destinations in the MPLS core network. Then when it gets there, it's a job of this BGP VPN v4 label to allocate traffic to their respective routing tables for the customers. So that's the basic architecture for MPLS, MPLS architecture. And then previously we looked at segmentation between two switches. It could be backhauling. It could be let's say campus network from, let's say, building A to building B. So that's basically data traffic being isolated over the core network. Thank you for watching this video, and see you in my next video.